Hi guys, welcome to the one lecture for this week. We are going to be continuing talking about moles, and more specifically we are going to be looking at how to convert between not just moles and grams but also moles and particles. And you'll see I have a couple of words here for particles. We'll talk about why that is coming up. But before we do that, I want to talk about calculators for a minute. Whatever calculator it is that you are using, you need to be able to use the scientific notation function in your calculator. That is not the caret button. Okay? The caret button is always a problem because when you use the caret button, you are likely to misenter something. And if you do that, you're going to get the wrong answer. So I would like for everybody to take a few minutes and learn how to use whatever calculator it is that you have to do this properly. So I'm going to run through on the next slide the four most common calculators that I see in the classroom. But if you guys have a different calculator, that is 100% okay. I will help you learn how to use your calculator. But you really need to know how to use this scientific notation button. It is going to make life much, much better, okay? So if you have a TI calculator, you might have a button with an EE on it. You might have to hit the second button and then find the EE, which on the big TI-84 pluses is actually where the comma is, and I'll show you this on the next slide. If you have a Casio, you might have a totally different button. You might have an EXP button or even a times 10x button. So when I look at these this next slide with the calculators, I want you to make sure you know which calculator method you should be using and take a minute and literally write down what buttons you're going to push, because if you push the wrong information into your calculator, obviously you're going to get the wrong answer and then you're going to be frustrated. So let's take a look at the most common calculators. Okay, so starting over here on the left, this is the graphing calculators that the school uses. Now, if you have one of these, okay, these do scientific notation, and what you're going to look for is you're going to see where right above the 7, right here, there's a comma button. And I know it's a little fuzzy on the slide, but in blue right there it says EE. So to get to the blue, you have to push this second button. So when you punch a number into scientific notation, and I'm going to use Avogadro's number as an example, right? You want to get in the 6.02 times 10 to the 23rd. That's the number that we're trying to punch into our calculator. You will punch in 6.02, then you will hit this second button. So then you hit second, and then you hit comma. So second, and then you hit comma, right? So that's the EE button. On your screen, what you will now see is 6.02E, and then you punch in whatever the power is that you want, 23, okay? So notice there's no time sign, there's no number 10, there's no caret, just 6.02 second comma, the E pops up, and then straight to the power, 23. Okay. If you do it this way, you will not have to use parentheses, and it will automatically give you your answer in scientific notation back if your number is big or small. So this is the TI graphing calculator. If you are using one of the school's smaller TI calculators, and I have some of these in my room as well, okay, in this calculator, it's a little bit different. Here, you do not have to hit the second button because the EE button doesn't require it, right? So here, you would punch in 6.02, hit the EE button, and then the power. Again, no time sign, no 10, no caret. And when your answer comes out, if you see up here on the screen, you've got the answer and then the power is here. So this would be 1.23 times 10 to the 99th power. Okay, so these have an EE button right here. Now, I also have some Casios. I personally like Casios better than TIs. So again, if you have one of my Casios, I think these are the two that I have in my room. and these are the two that I see the most. These are a little different. So here, if I want to punch in my Avogadro's number, I'm going to hit 6.02, and then now the button I want on the Casio's tends to be down here at the bottom. It says EXP for exponent. So again, 6.02, hit that EXP button, nothing else, and then go straight to the power. Okay. And then lastly, the pink ones, okay? The pink ones, I've also seen some folks buy their own and they're baby blue, but what you're looking for here is this button, which says times 10x. So again, you punch in 6.02, hit that button, no time sign, no 10, no caret, just this button. It takes care of everything, and then the power, okay? Now, if you happen to have a calculator that is not one of these, all you have to do is tell me what you have and I'll look it up and I'll tell you how to use it. But I want everybody to be using the scientific notation function on their calculator, not doing the old school parentheses times 10 caret power in parentheses. That's a lot of opportunities for mistakes. Whereas here, you push the one button and it takes care of all of that for you, okay? So now, just to be sure we're doing it right, I want everybody to try punching this into their calculator. All right, so punching it in using whichever kind of calculator you have, because you've written down what you're supposed to do, right? Punch in 27.5, and remember we multiply across the top, so times 3.8 times 10 to the negative 19th using your proper scientific notation button, whichever kind of calculator you happen to have. Okay, so punch that in and then look at your screen. And what you should get now, I'm rounding mine off for sig figs, you should get something like 1.05 times 10 to the 21st power. Now, if your power number is different, it means that you have punched in an extra number on your calculator. Okay. On my TI, let me just write it down for the sake of clarity here. Mine looks like this on the screen. All right, this E means times 10 to the power. So that's why I wrote it like this. The E on paper doesn't really mean anything, guys. You need to write it back the correct way. Okay. If your exponent is off by 1, it means you've punched in something wrong. It means you've added a time sign or a 10 or a caret, something you weren't supposed to. If you punch this in just like I'm saying out loud, 27.5 times 3.8 scientific notation function, whatever yours is, 19 equals, this is what you will get. If you are not getting this number, right now, before you go any further, reach out for help. Okay, it's an easy fix. I just have to know what you're doing. And the way I do that is I look at your calculator screen. If you're at home, you can take a picture of your calculator screen and I'll be able to tell you. Okay, so now that we've gotten that under control, let's talk about what we're actually doing today. Okay, we're going to be doing yet and still dimensional analysis. All right, what we're going to add to it, these are the two from last week. Right? We're going to be adding one more conversion factor. We're going to bring that Avogadro's number into play. So remember that Avogadro's number is how many particles are in a mole, just like 12 are in a dozen. 6.02 times 10 to the 23rd is our number that goes into a mole. We can write our conversion factors on top of each other, just like we did last week. Or, and this is how I'm putting them on my slides here coming up, just because this is the only way they'll all fit. We can also do them this way, where we're not committing to what goes on the top or bottom. We're going to let the problem tell us, okay? So this, using this conversion factor here, this is our big new thing for the day. And we've already talked about why we do it. We're just adding the math step, okay? Let's talk about the particles word, because I did put particles on the previous slide. And the reason I put particles is, remember, the definition is it's Avogadro's number of something. So what that something is will determine what we say. I would say a dozen eggs. I would say a dozen donuts, right? A dozen balloons. Here, same thing. I would say a mole of eggs, a mole of donuts, a mole of balloons. But I'm in chemistry, so I'm not doing eggs and donuts and balloons. I'm doing chemistry stuff. What kind of chemistry stuff? Well, I'm doing compounds. If my compound is covalent, I'll use the word molecule because that's technically what it is, right? If I'm using just a plain old element like carbon or sulfur, like in the video, right? I'll use the word atoms because those are singular atoms of a particular element. I could use the word particles if I'm talking about ions. So if I want to know how many particles I have, okay, or how many ions I have. And then the tricky one is ionic compounds. So remember that in ionic compounds, we're just talking about that lowest ratio. These are actually called formula units. So when I say NaCl, that is the smallest neutral unit. And yes, I am aware that when you try to abbreviate formula units, you get FU. And so if that makes you happy because you're not real thrilled with chemistry math, that's okay. It won't hurt my feelings. But a mole of ionic compounds are formula units, whereas a mole of covalent compounds are molecules. So the word changes, the number does not. So here we go. Let's do a couple. Okay, so these are going to be just like we did last week. The steps, you'll notice, are exactly the same. Okay, so we're going to follow the same steps. We're going to trust the same process. Now, the numbers are going to be not as nice, but that's okay. We're using a calculator. All right, so here we go. We start by number 1, writing down the given. So 2.5 moles of that NaOH, which I got right on your paper this time. Okay, and that was step 1, so done. Step 2, bring down the units. So my words come down here. All right, draw a little line longer here. That's step 2. And then step 3 is complete the conversion. Well, last week we only had one thing, right? We had grams and we had molar mass from the periodic table. This week we have a choice. We can go from moles to grams, or we can go from moles to particles, right? So what I would say is I've already put moles on the bottom. These both have moles in it. That means I can use either one. I can use whichever one I want. Literally ask yourself, do I want grams? The answer is no, I don't want grams. So maybe this is not what I'm using. Do I want particles? As in this case, formula units. And the answer is yes, I do. So I'm going to use this one. So now in step 3, I'm going to have to decide which conversion factor will do for me what I need it to do. And once I've got my units, then I can look here and see, okay, it's 1 in Avogadro's number, 1 with the word moles, and Avogadro's number with my particles. Okay. Now's the calculator work, right? 2.5 times 6.02, scientific notation button, whatever that is, times 23. With sig figs, I get 1.5 times 10 to the 24th. Okay, and these are formula units of NaOH. Again, right now, if you are getting a number that is different than 24, please speak up, either out loud or via text or something, right? Let's get this figured out. It's a quick and easy process to fix. I just have to know that it needs to be fixed. Okay. All right, let's do another one. Actually, this one I'm going to do both of these with you. So this one is 2.5 grams of NaOH is my given, and I'm going to go to formula units again. All right, so again, trusting in the process. So 2.5 grams of NaOH, that's step 1. Okay. Step 2, bring down those units. So here they come down here, grams of NaOH. Step 3, complete the conversion. So I'm coming up here to my two choices, and I've already written the word grams on my paper. So that means I have to put moles with it, even though, that's not actually what I want. But it doesn't matter. I have to do it because that's my option. So I'm going to look up NaOH, and we did this one last week, so I tried to keep it kind of simple. Okay, so I'm going to do this. Only problem is right now my answer's in moles, and that wasn't what I was asked to find. So this is where something new comes in. Okay, if this unit here is not what you want, right? If I complete the conversion and it doesn't give me what I want, that's okay. All I have to do is repeat step 2. So I draw another line and I pretend like it's a brand new problem. I bring these units down. And then I go back up to my list and I pick again. All right. I have moles on the bottom. I'm not going to turn it back into grams because that'll undo the work I just did. But I have moles on the bottom, and I could change it now to Avogadro's number of particles. So that is what I'm going to do. Okay, so what's different here? This one has more steps on paper, but in practice, it's the same problem-solving approach. Okay, so everything before was only like 1 conversion long. Now our problems can be 2 conversions long. But I'm not going to worry about that when I start the problem. I'm going to just follow this process and let it lead me down the path that I need to go down, and that will determine if it's 1 or 2 steps. Okay. So for solving, just like before, we are going to multiply everything on the top together. So 2.5 times 1 times 6.02 to the 23rd divided by 40, right? And I get 3.8 with sig figs times 10 to the 22nd formula units of NaOH with sig figs. Okay. Again, check your exponent, guys. So this step right here is our new step. Now I have 2 more for you, and then we're going to try some. Okay, or you're going to try some. Okay. Now, if you're at home, maybe you want to do some on your own. That's fine now that we've done 2, or you can keep watching. 3.5 is my given, times 10 to the 15th, and this says atoms of AU. Okay. Now, a lot of times people see that scientific notation number in a problem and they freak out. Guys, don't freak out. It's just a big number. That's all it is, right? You don't treat this any differently than anything we've ever done. This is just the given, and you write it down. Okay? You still do step 1. Step 2, you still just bring down the units. The units are atoms of gold. Okay. Now, step 3, complete the conversion. So you come up here. The one from last week has moles and grams in it. It does not have atoms in it, so it's not this one. The new one has moles and particles in it. Particles can be atoms, so this is the one that we're going to pick. The word atoms is already on the bottom, and so now I'm going to put the words moles on top. Okay, once I know where my words are, I match up my units to the words. Okay, all right, now let's talk calculator. This is in scientific notation. So when you put it in your calculator, you're going to put it in scientific notation. 3.5 E, right, whatever it is in your calculator, EXP, 15 times 1, then divided by 6.02 EXP, 23. Right, you go straight into scientific notation. You don't have to use parentheses at all if you're doing it correctly. And then you get, with sig figs, 5.8 times 10 to the negative 9th. And remember that that negative 9 doesn't mean that it's a negative number. It just means that it is a very very small number. Now, if by chance your calculator does this to you and it gives you a number like this, please don't panic. This is the same exact answer, right? This is that number up above, just not in scientific notation. I don't know why some calculators automatically do it all the time and then some just randomly decide not to. But if it decides not to, remember that you can just 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So that's where the -9 comes from. I prefer scientific notation, but this is not the end of the world as long as you write it with the correct number of zeros. So don't panic if it doesn't give you the exact same number. Maybe it's just giving it to you not in scientific notation. All right, one more, and then I'm going to set you guys loose to try some. This one has, again, the same given, 3.5 times 10 to the 15th atoms of gold, because we're trying to keep it easy. Okay. That was step 1. Step 2, bring the units down. Done. Step 3, fill the rest of this in. Okay. So I already wrote the word atoms down. This first conversion does not have the word atoms in it, so I can't use that one. The second one, though, has moles and particles can be atoms. So I'm going to use this one. So if atoms are already on the bottom, moles are going to be on the top. And it is the number 1 and the number 6.02 times 10 to the 23rd. Okay. Well, crud, right? That wasn't what I wanted. I was trying to get grams. Well, you know what? It doesn't matter that I was trying to get grams. This is what I had to do. So I'm going to go and repeat. Okay. So draw the box. Bring these guys down. Go back to my list and try again, right? If I have moles on the bottom, do I want to turn it into grams? Yes, I do. So grams of AU. And then that says 1 mole. And then the grams, remember, we get this off of the periodic table, so I went ahead and looked it up. It is 197 even. Finally got what I want here, so now I'm ready. Okay, multiply across the top. 3.5 exp 15 times 197 divided by 6.02 exp. With sig figs, I get 1.1 times 10 to the -6th grams, which is not a lot, right? It's a tiny little bit of a gram, not a negative amount, but just less than 1. Okay. Now, our numbers just got ugly. I am aware. That is okay. That is why we use a calculator. Okay. When you set these up to do your classwork, homework types of things, remember that what you get are, I actually give points for each individual step. So you get points all along for these problems. You get points for knowing how to write down the given. You get points for picking and completing each conversion factor correctly. And you get points for your answer with units and sig figs. So as you go through and you set up your problems, if you get everything set up correctly, right, but you don't get the sig figs or units right, well, you know from our previous assignment, right, you lose a little bit of points for units or sig figs. Earn points for the numerical value that is your answer, right? This is usually half a point. And then you earn the points for these other steps as well. So you're getting points for each individual step. So this problem might be worth 4 points. All the setup is actually worth more than the final answer because this final answer is just a calculator game, but the process is very important. So showing all your work definitely works to your advantage. Okay, so before you jump in, let me just remind you that what you need to do is know what your options are, right? We only have 2 things we're allowed to do now. We are allowed to put 1 mole with the molar mass from the periodic table. And we are allowed to put 1 mole with Avogadro's number worth of particles, atoms, molecules, formula units, ions, etc., right? Know how to use your calculator. Know how to use scientific notation. Do you use the comma EE button, right? Do you have an EE button? Do you use EXP? Do you have a times 10 to the X button? Do you have something else that I showed you? And then the last thing here is use dimensional analysis steps. Trust and use these steps. Show your work, keep track of your units. That's how you're going to know whether or not you should stop or do another step, right? So do one step at a time. Do not try to memorize where does something go. Instead, trust the steps. Trust the method. It works, okay? After break, we're going to be adding some more things to it. It's going to be exactly the same method. Okay, embrace it. Okay, so my final advice to you is that in order to master this skill, it's very straightforward. You have to practice, right? Just like you have to practice a musical instrument, just like you have to practice your skills and drills if you play a sport, you have to practice and flex your academic muscles. Okay? If you aren't sure what's going on, you have to ask questions, right? Don't just sit there and say, well, I just didn't know how to do it, and that's why I'm not doing anything. That's not how you get the answer, right? Ask questions. And then the last thing is don't fight the process, okay? I've been teaching chemistry over 25 years. Right? I am trying to teach you the most reliable, easiest, most straightforward way to do things, right? There's a reason that I'm asking you to do it this way. So don't try to reinvent the wheel. Don't fight the process, okay? Learn how to work the steps. And that is how you will master this. And then all of this chemistry math is going to be easy, right? And you're going to be able to tackle it and master it and look forward to the fact that anytime you have a problem that includes this kind of math, that you're going to know that you totally know how to do this. And it's going to be easy points. And that is what we want. So now you can go on and you're ready to practice. First, very structured and guided, and then more independent.